Hello everyone, in this video we're going to be solving a geometry puzzle. Three congruent circles with the radius r are inscribed between two quarter circles with radius 1 as shown. Find r. Remember in a previous video I had told you that I'll bring some variations of that problem, and this is actually one of them. Alright, so last time we had two circles that were stacked up inside, and this time we have three, and they're kind of horizontally situated. So at this point, you may just want to pause the video and try this problem yourself first. Okay, let's get started. Now we do have three circles that are congruent, okay? And their radius is r. We're going to find r. But what we know is that we have two quarter circles with radius 1. In other words, we have a unit square here, right? Okay. So let's see what we can do. And as always, we're going to make some important connections. Okay, so one of the things that I'm going to do is connecting the centers of these circles. That kind of looks good, if we do that. So we can kind of go like this, right? And then what other connections can I make? Well, I think one of the most important connections here would be, because my goal in these puzzles, as you know, is to get a right triangle, in which I can use the Pythagorean theorem, right? And obviously, I need to take advantage of the fact that the radius of the quarter circles is 1. So I kind of need to associate that. So here's how I proceed. From the center of one of the quarter circles, I'm going to draw a radius, okay? And that radius, as you know, is going to go through the center of one of the circles. So it's going to go like this. And that's actually very critical. This is a very critical connection here. Here we go. All right. And then how do we proceed from here? Well, here's the idea. Okay. So this is R, this is R, this is R, and this is R. Awesome. Let's go ahead and draw a perpendicular line here. So kind of drop the height, sort of. Okay. So that's going to be another critical connection here, because this is also R. Okay, so here's the thing. If I can find the side lengths of this triangle in terms of r, then I'm good to go. That way I can just find r, because the only unknown is r, and the only thing that I know basically here is the radius of the quarter circle, which is 1, right? That's all I have. But this can be done. Why? Because these circles, since they're congruent, can only be inscribed in this region in one way. Okay, so the solution is unique. Awesome. Here is how we proceed. This is also radius, r. Now think about this segment here between these 2 points. What does that look like to you? Well, you guessed it right. That is the radius of the quarter circle, which is 1. Therefore, if you subtract r from it, what's going to remain, right? Then you'll have 1 minus r left. So this piece here is going to be 1 minus r, and that just happens to be the hypotenuse. Beautiful. So I got the hypotenuse in terms of r, I got the height in terms of r. If I can find the base in terms of r, then we are good to go. But how can I do that? That's kind of like the important part of it, because it's not as easy as it looks. Okay, I don't know this piece, but guess what? I can find it. How do I find it? Okay. To find it, we're going to be taking advantage of the symmetry again, right? Remember, in another video, we use symmetry, and symmetry is actually very, very helpful. So how do we use symmetry? Well, these two pieces have the same length. Beautiful. Well, then I got a rectangle here, didn't I? A rectangle whose height is r and whose base is 4r. So this is 4r from this point to that point. Okay, that's 4r. And those two little pieces, you can call them a if you want, or x, whatever. Let's just call it x maybe, yeah? Why not? Okay, so let's call that x. What do we know? From symmetry, they are congruent, obviously, right? I can't find it directly, but I'm going to find it indirectly. How? Well, the sum of the lengths here is the radius of the quarter circle again, which is 1. Therefore, I have x plus 4r plus x equals 1. Beautiful. What's my goal? my goal is to find x in terms of r. So let's go ahead and proceed. I'm going to add x plus x, which is 2x plus 4r is equal to 1. And then I'm going to isolate x because my goal is to find x. Not actually, but indirectly I'm going to use it. Okay, so 2x is going to equal 1 minus 4r. If you divide both sides by 2, then x equals 1 minus 4r all over 2. So this is equal to x. What I need to do is actually the base of the right triangle. And what is the base of the right triangle? There are two ways to approach it. You can either call that 1 minus x, right? Because this piece is x, and I need to subtract it from 1 to find the base of the right triangle. And this is the right triangle I'm talking about. I just shaded it, right? Okay, that's the one. Or I can do it differently. What I can do is I can add the x and the 4r. Same thing, right? It's going to turn out to be the same thing. But I will go with x plus 4r. That seems a little easier. Okay, so let's go ahead and find x plus 4r. That's going to be the base of the right triangle. Okay, so since x is equal to 1 minus 4r over 2, then I'm going to be adding 4r to it. And when I make a common denominator, this is going to be 1 minus 4r plus 8r divided by 2. From here, I should be getting 1 plus 4r over 2. So I can call that b for the base, but that's not necessary. We know that it's the base of the right triangle. The height is r, and the hypotenuse is 1 minus r. Let me write that down one more time so that it's more clear. Maybe right here, 1 minus r is going to be the hypotenuse of this right triangle. Because the whole thing is 1, I subtract r from it, and I end up with 1 minus r. So now we do have a right triangle whose base is 1 plus 4r over 2, whose height is r, and whose hypotenuse is 1 minus r. Beautiful. I got what I need. The rest is just computations, right? But let's go ahead and calculate because it's going to be fun. We're going to get a nice result, and then we'll talk about it. Okay, so let's go ahead and proceed. How do we proceed? We have to square a quotient here, so it's going to look like 1 plus 8r over 16r squared divided by 4 plus r squared is equal to 1 minus 2r, not r squared, 1 minus 2r plus r squared. Obviously, r squared cancels out, which is kind of nice. We still get a quadratic, but it's a little better. Okay, let's go ahead and cross multiply here. 16r squared plus 8r plus 1 is equal to 4 times the quantity, 1 minus 2r, which is equal to 4 minus 8r. Then add 8r, you're going to get 16r squared plus 16r. And then subtract 4, 1 minus 4 is equal to negative 3. Awesome. Now we got a nice-ish quadratic equation. Let's go ahead and solve it. This is not factorable because it doesn't have rational solutions. How do I know that? Well, in order to be able to draw this picture, you need to calculate r ahead of time. All right? Otherwise, your picture is not going to be right. Okay. So this is not approximate. This is exact. All right. So let's go ahead and write down the solutions. R equals negative b plus the square root of b squared, which is 256, minus 4ac. You know, the infamous quadratic formula. Divided by 2a, which is 32. So what I will do here is, to make things a little easier, I'll simplify this as much as I can, and then just change the plus minus. I might as well just write plus minus there, right? To make it easier. Why don't we split right away? Because then we're going to have to double the work. We just want to simplify everything under the radical and then split it up. All right, let's see how this goes. So one of the things that you can take advantage of here is, first of all, negative times negative is positive. So consider that. Plus, you have 256 and 16, which means that they're both divisible by 16. But moreover, you have a factor of 4 here. So 4 times 16 is actually what? A perfect square. So what I can do is I can write this as 16 times 4 times 4, because this is 16 times 16, plus 16 times 4 times 3. Beautiful. Look at that. Check it out. So 16 times 4 is a perfect square, and its square root is 8 because it's 64. Or you can take it out as a 4 and a 2. Whatever you do, you get 8 from there. So I have negative 16 plus minus 8 times the square root of. What do I have under the radical? 4 plus 3, which is 7. Wow, that was easy. Divided by 32. Beautiful. What's next? Okay. The next step is actually fairly easy because all I have to do is simplify this fraction. But before we do that, let's go ahead. Well, maybe before we're going to do that first. Okay, never mind. So what I'm going to do is I would like to divide everything by 8 because 8 is a common factor. So I should be getting negative 2 plus minus rad 7 or radical 7 or square root of 7, whatever you want to call that, divided by 4. Beautiful. At this point, I can just go ahead and split, right? Okay, let's go ahead and split the plus minus into two solutions. Let's see what happens. So R1 is going to equal negative 2 plus root 7 over 4. That's going to be one of the solutions. The other solution, R2, is going to be negative 2 minus root 7 over 4. But guess what? This is negative. Do we want a negative radius? No, we don't want that, okay? That's no good. Radius cannot be negative, it's length. Okay, so this is our answer. You can write it as root 7 minus 2 divided by 4 as well. No big deal. It doesn't really matter. But that's the radius of the circles. You can also call that R, I guess, because we said that finding R was our goal. So I'm going to write it as R here. So this checks and this doesn't. So this is going to be my answer, the radius of the circles. Square root of 7 minus 2 divided by 4. And that will be the radius of each of these circles here. All right. I hope you enjoyed the video. Please comment, like, and subscribe if you haven't already done so. And I'll see you in the next video. Until then, take care and be safe. Bye-bye.